Hello, everyone. I'm Paul, co-founder of Submer, and we help build and upgrade to data centers that make sense. Data centers that are more sustainable, cost-effective, flexible, and powerful. Data centers and cloud providers, as of today, are getting bigger, hotter, more expensive. Some trends indicate that they may consume 20% of the global electricity. As of today, compute consumes more electricity than India, which is crazy. This translates into more or less more than commercial air travel. And basically, traditional cooling and basically building technologies cannot keep up with this growth. So what we see also is a limitation on the physical size of transistors in semiconductor companies. So the Moore law is ending. And what we see is an impact on the data center density. So these are some research papers. As you can see, the growth is not only growing linearly because of the demand on the applications, but also exponentially. A typical data center using evaporative cooling technologies evaporate a swimming pool every 2 days. Another crazy impact fact. And also data center building technologies basically make data centers a huge and time-consuming project, which more or less costs around 5 to 10 million per megawatt of power. And also, basically, hyperscalers need to grow faster than what's actually possible. Moreover, all these hyped buzzwords around crypto, blockchain, AI, metaverse, all these things require hardware that is even more dense, which is impossible even in some cases to refrigerate with traditional air cooling. And then we see more and more delocalized data centers in order to reduce the latency. So edge computing in general, but 5G, smart cities, IoT, machine-to-machine communications, etc. Out of the 17 United Nations sustainability goals, 9 of them are affected, more or less, by data centers. And this is the solution. So we created a full-stack active immersion cooling technology that allows us to submerge any kind of compute, any kind of electronics in these jacuzzis for computers that makes it orders of magnitude more efficient than traditional technologies. It has its brain, the cooling distribution unit. It has a busbar system that also optimizes the AC to DC power conversion. It has compatibility with traditional enterprise servers or 21 inches open compute. And basically, as you can see, electronics are directly submerged in the fluid. All this fancy stuff basically means slashing virtually by half the operational costs of data centers, reducing a lot the capex. We don't care about these very expensive wide rooms. We can deploy on them, but we are actually saving from day one in greenfield data centers. It has a software stack to monitor everything and easily interconnected with your existing infrastructure management software applications. And this means a much better TCO, so much better total cost of ownership, much better sustainability impact, and all that without wasting water, but actually empowering the circular economy by being able to reuse the heat that the computers generate. So a couple of upsides: heat reuse and also overclocking capabilities. This translates into swimming pools being saved, cars out of the road, etc., etc. Submer is not extremely compelling under the TCO perspective, so it's getting also mandatory over time due to the regulations and due to the chip density race. The data center market is set to grow 300 billion until 2024. Basically, it's a growing market. Even today, it's record hikes growing, even in this downturn market. And we had a broad spectrum of applications, from the edge computing to the hyperscaler and anything in between. The business model as of today is selling the physical platform, but we already see organically how data centers and hyperscalers request from us services, maintenance, operations. These guys are very used to pay a lot of money for supporting their infrastructure, but also services like build, operate, and transfer, so that we can certify some equipment, or we can stress test some of the systems, or we can provide infrastructure as a service, etc., etc. So over time, growing on the stack of services and recurring revenue. We are very well positioned in this market. Actually, we grew faster in half the time than our closest competitor because we are the single company in this space owning the full stack understanding of the technology, the fluid, the hardware, the cooling distribution units, the thermodynamics, the software, all this mix of things that before were separated, we converge them in this solution that makes data centers more sustainable and cost-effective. Then there are all these on-chip liquid cooling technologies that even in the 90s gaming PCs, all these heat sinks with pipes and so on, they only solve partially the problem, the density problem, but then you need to add extra costs in the most expensive part of the data center, being the compute. So basically the TCO is not as good, and then you need still some air cooling and so on. In any case, our biggest competitor is 50 years of doing the same thing somehow with traditional technologies. We are a team of engineers, PhDs, and business people with extensive experience managing teams and creating companies, and also in this type of corporates. For instance, also with key advisors like the ex-corporate VP of Intel or the ex-infrastructure director from Apple and Yahoo, but very, very senior team members also that interface with this market. We are about to open a growth funding round next year, so join us in this exciting journey. We already surpassed the 10 million a year revenues. We are growing at 400%, and we have a pipeline which I need to update the slide because it's actually 500 million as of today. So the thing is getting a lot of momentum, and we like sustainability investors. So basically, you can join Norsken from Sweden or Planet First in London in this exciting journey. Basically, we have deep relationships with key companies like Intel. The time is now for immersion cooling. Our collaboration with Submer will allow us to address all the stages of immersion cooling value chain, et cetera, et cetera. So basically, semiconductor companies need liquid cooling, and among liquid cooling companies, we are the best well-positioned in this space. So basically, a few pictures of the solution, how it looks in different form factors. This is for edge, for instance. It can be deployed even without a building, for cell tower 5G deployments or edge computing. This is a hyperscale deployment, multi-megawatt. This is, I think, a video of one of these big deployments. So it looks a little bit nicer and also sounds much nicer. If you've ever come in or went into a data center, it's very, very noisy. This is silent, and it's like a little bit of a zen, relaxing environment. Yeah, sounds like a little bit like a fish tank, but more relaxing even. And then I think there are some sexy piping here. These pipes can be then connected into a heat exchanger so that we can reuse the heat for district heating, or for instance, as you can see, all these things can be somehow replaced by heat exchangers so that you can reuse it for, even in some cases in the Nordics, we are doing aquaponics or farming. These sort of things in colder climates are very interesting. So this is an upside that some customers start to use. And these are some of the examples on the containerized implementation, so popping up a data center wherever we want. These are some of the strange use cases also for the mining industry and crypto mining, which is, even in this market, it's actually better for us because we are getting more customers because of the upside we bring on overclocking capabilities. So very, very flexible on these different types of applications, from hyperscale to HPC to telco to enterprise and so on. That's Submer. Hope you enjoyed. And yes, if you have any question or you want to invest, please reach out to me at paul@submer.com. Thank you.
Thank you, Paul. We have time for a couple of questions. Any questions? Here we go, one.
Hey, Paul. How do you address the security access to the facilities that the CSP working with?
So basically, we can deploy this in a regular data center. So even if we can simplify a lot the CapEx on the building and can be much simpler, we obviously recommend to have security in the building itself. In the containerized modules, we can work in different manners. We can place different security systems in the containerized module. But we are flexible. In the end, we are agnostic to what you put inside, which compute, and where you put these boxes. It's very modular. So yeah.
Any other questions? No? Well, thank you very much,
Thank you.
Paul. Thank you so much.